Good morning. Our topic today is about inscribed angles. But before we proceed with our discussion, let me ask you this question. This is just a review of our previous topic. What is a central angle? Anyone? Okay, so a central angle is the angle that forms when two radii meet at the center of a circle. So let's now proceed with our topic, inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords. So we have here four illustrations. And illustration 1 says that this is not an inscribed angle, or it does not show an inscribed angle. Do you know why? Okay, because the two sides of angle 1 here are not chords. Okay, because our description for the inscribed angle is it is an angle whose vertex is on a circle and whose sides contain chords. Illustration 2 says it is an inscribed angle, or it shows an inscribed angles, because the two sides of angle 2 here are chords on a circle. Illustration 3 is not an inscribed angle, or it does not show an inscribed angle. Again, because the two sides of angle 3 are not chords on a circle. But my question here is, if these two sides of angle 3 are not chords, what are they? Okay, they are the radius or the radii of the circle. Okay, so if illustration 3 is not an inscribed angle, from my previous question for our review, we call this as a central angle. Okay, let's move on to illustration 4. Illustration 4 shows an inscribed angle because the two sides of the angle are chords on a circle. Is that clear? Okay, do you have any questions? Okay, let's proceed. Okay, let's have first the vocabulary before we proceed to the next slide. Okay, vertex typically means a corner or a point where lines meet. And a chord of a circle is a straight line segment whose endpoints both lie on the circle. So we will always be using these words, vertex and chord of a circle, in discussing this topic. So please always remember these two words. Okay, let's proceed with the inscribed angle theorem. Inscribed angle theorem says that the measure of an inscribed angle is equal to half the measure of the intercepted arc. So this is angle 1. Let me use my pen to show you where the angle 1 is. Okay, so oops. This is angle 1. Okay. And then K here is the intercepted arc, and the intercepted arc is this part. Okay, so again, when we say inscribed angle theorem, that is the measure of an inscribed angle equal to half the measure of the intercepted arc. So the measure of angle 1 here is half the measure of K degree. Okay, let's proceed to the next one. So this is another illustration. So the inscribed angle here is this one, the 55-degree angle. Okay, and then the intercepted arc is the arc YZ or YZ. So this is the intercepted arc. Okay, so again, the measure of the inscribed angle is half the measure of the intercepted arc. So our intercepted arc is 110 degrees. So therefore, the inscribed angle is 55 degrees because half of the 110 is 55. Okay, so we can also remember this. Central angle is equal to the measure of the intercepted arc. So again, central angle is also equal to the measure of intercepted arc. And then the inscribed angle again, aside from it is half the measure of the intercepted arc, we can also say that the inscribed angle is also half of the central angle. Okay, so inscribed angle is equal to half of the central angle, which is also equal to the half the measure of the intercepted arc. Okay, let's have an example here. Find the value of x in the figure. So let me use a different color. This is x and this is unknown. Okay, so angle T here is the inscribed angle. And then our intercepted arc is arc PQ, which is 40 degrees. So again, the measure of our inscribed angle is equal to half the measure of our intercepted arc. The intercepted arc here is arc PR. So therefore, the measure of angle T is half of 40 degrees. So again, half of 40 degrees is 20 degrees. So therefore, the measure of angle T here, or x degrees, is 20 degrees. Is it clear? Okay, next. An angle formed by a chord and a tangent can be considered an inscribed angle. Okay, so a chord and a tangent. So tangent here is, let me use this one. The tangent here is this part. Okay, and it can be extended. Okay, so we will be discussing tangent later on. Okay, so again, an angle formed by a chord and a tangent can be considered an inscribed angle, which still be using the same formula. Okay. Okay, let us have this one, this illustration. So the measure of angle PRQ, this part, is equal to half the measure of arc PR. So this is arc PR. Okay, so again, the measure of angle PRQ, this angle or angle R, is half the measure of arc PR. Okay, let's have this example. What is the measure of angle PRQ? Okay, so PRQ is this, or angle R. And we have here arc PR. Okay, but we do not know the measure of arc PR, but we have an inscribed angle here, 60 degrees. Okay, since we have already discussed from the previous slide, which one? Okay, this one. The measure of an inscribed angle is equal to half the measure of the intercepted arc. So therefore, the inscribed angle is twice the measure of the intercepted arc, right? So going back to our question, since there is no measurement for arc PR, oops, not that one. There's no measurement for arc PR, but there is a measurement for the inscribed angle, which is 60. So PR will be twice the measure of this angle. So that would be 60 degrees times 2, which is 120 degrees. So therefore, arc PR is equal to 120 degrees. So we can say that the measure of our angle PRQ is equal to half the measure of arc PR, which is equal to half of 120 is 60 degrees. Okay, next one. An angle inscribed in a semicircle is a right angle. Okay, so again, an angle inscribed in a semicircle is a right angle. Let me show you the illustration for that. So, PR is a semicircle. So, it measures 180 degrees. And if we are going to have an inscribed angle out of this, we will be having this. Okay, so therefore, half of 180 is 90 degrees. So this is a 90-degree angle. Okay, a 90-degree angle, we all know that it is a right angle. Okay, so let's have more examples. Chord AC intercepts a tangent at point C. If the measure of arc ABC is 70 degrees, what is x? So this is unknown, this part. The angle C or x is unknown. But there is a given measurement. The measurement of arc ABC, which is 70 degrees. And ABC or arc ABC is this part. Okay. So x now will be, or angle C, or the measurement of angle C will be half of the arc ABC. So half of 70 degrees. So the measurement of angle C is 35 degrees. So therefore, the measurement of x is 35 degrees. Next one. Solve for x. Okay, so we have here an illustration and we are asked to solve for x. So the measure of angle ONP, the measure of this angle, is equal to 10x plus 2.5 degrees. Another given is the measure of arc OQP. So OQP, so this arc, the measure of arc OQP is 165 degrees. Okay, so again, this is an inscribed Angle N here is the inscribed angle, and OQP is the intercepted arc. So the intercepted arc is 165 degrees. So therefore, the measure of angle ONP is half of 165 degrees. And half of 165 degrees is 82.5 degrees. So we can now solve for x. Again, angle ONP is equal to 82.5 degrees. So we can use that. 82.5 degrees is equal to 10x plus 2.5 degrees. And then we need to move the 2.5 degrees on the other side. So that will become 82.5 degrees minus 10. That's minus 2.5 degrees is equal to 10x. Okay, so let me continue here. 82.5 minus 2.5 is 80. So 80 degrees is equal to 10x. So for us to get the value of x, we have to divide both sides by 10. So therefore, 80 divided by 10 is 8. So the answer is x is equal to 8. Do you have any questions? Okay, so if you do not have any questions, this is going to be the end of our discussion. Please get ready for a quiz tomorrow. Okay. Bye.